Let me just pass the slide here, if that works. Awesome. So my name is Martin. I'm also part of the performance engineering team here at Netflix. And I'm also here to talk a little bit about client performance, in my case, Icarus. So first thing that might come to mind when I mention the name Icarus is that Greek guy that tried to fly out of Crete in a pair of wings, his dad built, dataless. But he flew a bit too close to the sun, the wings actually melted, he fell to sea and died. Likely that's not the case here. Icarus, in our case, is a real user performance monitoring solution we built here at Netflix. It helps us get more insight into the app performance, the client performance, as real users perceive it. We have just too many variables and too many unknowns to trust only on synthetic tasks being executed on labs. So we need real user data to really get insight into app performance. It really helps us understand how changes we are making to our environment, to our client apps, or to our infrastructure, to our backend services, how they actually affect real users. It's also a great tool to detect issues in case we push out a bad build that introduces some perf regression in a weird device in India. We can detect that so we can troubleshoot and fix it. Same goes for bad issues with ISPs. An ISP in Germany having issues, we can go and reach out to them and see if we can actually help with that. So getting real user data is really important. That sounds really easy, really simple. You basically just sign up for a third-party service, right? You snap some JavaScript on a web page and problem solved. You just wait for those metrics to start flowing in. Unfortunately, that's not that easy for us. Besides of the scaling issues, we also run on all sorts of devices. It's not just web and mobile. We also run on smart TVs, a bunch of gaming consoles, your Xboxes and PlayStation, and even some weird cable TV boxes running Windows CE in Belgium. And we actually need to support that, and we care about that. So we need to find a consistent way of evaluating the performance in all those devices. Another thing, as Guy mentioned, we run everywhere. As of last year, we run everywhere with the exception of a few countries. So we have a really, really wide variety of networks we need to deal with. So we need to take that into account on our analysis. Because the same device might perform completely different depending on where you are. So what exactly are we monitoring? In the case of Icarus, we are monitoring user actions. So things the user can do in the app, like launching an app, opening it, navigating to a page, like getting details for a movie, for example, playing a title, things like that. So that's what we're trying to capture here. What are we measuring? And that's when the question starts to get really interesting. When does this timer actually start and end? And we had really, really long discussions around that. Short answer is it depends. It depends a lot. There's no standard that will define that, at least not for all the devices we have to support. So we had to create custom timers for basically each action we need to support, each user action. For example, app startup and navigate events, they will have at least two timers, being TTI and TTR. TTI is fairly well understood as the time from when the user initiates the action, when he clicks on a button or an icon, until that view or page is interactive. Things might not be fully rendered at that time, but the page is interactive. And then we also have to complement that, we have TTR, or time to render, which starts exactly at the same time as TTI, but it ends when all the items above the fold, or things that are visible without scrolling, are fully rendered. So we have that timer. The other custom things, so if the user is trying to play a title, we have play delay, which is the time from clicking on play until the title actually starts playing, and we need to keep track of that, plus a bunch of other metrics. The key item on this is the timers really need to track what the user is feeling, what the user is trying to do. That's the key part of this. We need to create timers that track what the user feels. We have really, really high dimensional data. Really complex device categorization. We have thousands and thousands of combinations of devices, platforms, apps, versions, and so on and so forth, and we need to be able to split all of those. We need to take geo into consideration, regions, countries. A lot of our customers are, internal customers are part of our CDN team, so we need really granular network classifications. So your ISP or the ASN, the ISP network you're talking to, or the AWS region you're talking to, or if you're over Wi-Fi or cellular network. We run a lot of A/B tests too. So, and those A/B tests might affect how the client behaves, how the app behaves. So we need to track those too. We need to track A/B test out to see if the user is getting a different experience or not. Some actions also have different facets. So app startup, for example, you might have a cold startup or a warm startup, and we need to keep track. We need to be able to differentiate those because those are really different things. Now that you know a little bit of what we're trying to track and what we're trying to achieve, I'll go really quickly through how we actually make that happen, how we capture all this data and how we process that. So we have all our devices, all our user devices. They run our client. The client implements those timers. They capture the timers where the user tried to do something. It buffers in the client and then flushes to our data pipeline every hour or so, depending on network conditions, if things are good or not. It just flushes to our data pipeline, and that ends up in Hive, which is one of our data warehouse solutions. Even not being fast metrics, like I mentioned, the volume is fairly considerable because this is not sample data, it's everything. You want to see everything. Obviously, this creates a few challenges on how we process that, how we analyze that, and how we actually present that in a meaningful way. We try a bunch of different things. But first iteration, let's just try and plug that to Tableau. I don't know how many of you actually know Tableau, but that didn't work out well at all. We blew that thing away really quickly. Next thing, we decided let's just try Druid. Druid is really great. It's distributed. We can scale up and down. That works great. It's impossible to load all that data into Druid. So, okay, great. Let's just try to pre-aggregate, like pre-calculate a few percentiles and a few statistics, and then obviously split by all those dimensions, upload that to Druid, and then we can aggregate all of that in Druid. If you guys don't know what Druid is, imagine it as a cache in front of a Hive table, for example, where you can run functions on that cluster on top of that data, which works really great for us. Because we can actually aggregate data in Druid, and it works really well. Problem is, to present that in a meaningful way, we need to roll up those percentiles and those statistics, right? And the only way of actually getting that done in Druid itself is using weighted averages. And as you guys might imagine, using weighted averages on top of percentiles, it's not great at all. We knew that, so obviously we decided to evaluate if can we actually live with that error or not. As it turns out, the mediums are not that horrible. They were fairly okay for most use cases, but the ends, I mean, the top and bottom percentile, those are really horrible. And we couldn't really live with that at all. We needed something better because that data could lead us to some really, really bad decisions. That's when data sketches came in. I don't know how many of you are familiar with data analysis and data sketches. I don't want to get into too many details, but basically, in summary, it is a data structure that resembles some bigger data set, but it still preserves some essential features of that data set. The advantages of actually doing that and using that is because the output, the new data set, is significantly smaller. It's way, way, way smaller. And it's much faster to operate on. So it could do things in real time, which is great. There are a bunch of options you could use in cases like ours. Like Yahoo has sketches, and there's a ton of those. But we opted to use tdigest as our data structure for sketches. I will not get into details of tdigest. You can get more details on GitHub, on Ted Dunning's page there. But it's a really great sketch if you're working with rank-based statistics, including quantiles. it works really well in parallel systems because you can create all of those small sketches, and all of those sketches are really easily mergeable. You can merge them really easily and then extract the quantiles out of that. Extremely fast, and like judging by our tests, it's really, really accurate, a lot more accurate than their weighted averages. So we decided to go with that. Great. So we process all those small sketches with Spark jobs. We upload those to load them on Druid, and then we build the module internally here to go and merge those small sketches and basically give us our quantiles and a few other statistics we care about. Great, excellent. That gives us querying capabilities, but like performance engineering team, we're not the only consumer of this data. We also need to present it in a nice way for other people. We have our client teams, the teams actually developing the client apps. We have our CDM team that actually consumes that data, plus a bunch of other teams. And they tend to prefer a UI to go and query that data. It also needs to be flexible to actually accommodate all the needs from all those teams. So we decided to build a custom React and Node.js application, still developing heavily on that and improving every day. And now I'll go quickly through a few use cases of that app we built. A very, very common use case for us is comparisons. People like to compare things, compare different items in the same dimension. Obviously, different teams, they would care about different dimensions. Teams developing an app would care more about platform categorization dimensions, for example. Teams working with networks would care more about the network dimensions. So the UI needs to be super flexible. It actually allows you to filter and group by any of the dimensions I mentioned previously. So it's really, really flexible. And in this case here, I'm pretty sure I have only iOS selected as a platform. I'm only plotting mediums. I only have one action, which is cold app startup TTRs and time to render. I only have a few countries selected: Brazil, India, Mexico, and United States. And I'm breaking by country. I'm comparing countries. A simple time-based chart. You have on the x-axis, you have your times, and the y-axis, you have the timer durations. As you can see, what looks pretty interesting to me, at least, is that Brazil, for that app TTR app startup, is taking longer than India, which is not something I would normally expect because, well, India is a lot far away. Then we can do something interesting. We can add an extra filter option. We can lock to a single device, in this case, iPhone 6s. Great. That changed quite a bit. You can see that India now is taking a lot longer than Brazil, this example. That's because we have bias in the data. And we need to be aware of that. Everyone analyzing the data needs to be aware of that. So we like to always stress that to use. It doesn't just pay off to have all this data available if you don't really know how to analyze it and actually read it. So we like to always emphasize that. Different visualizations. We're trying obviously different visualizations. In this case, you have a CDF or a cumulative distribution function, where in the x-axis this time, you have the transaction duration there. And on the y-axis, you have the percentage of all those transactions that completed in less time than that. So different way of visualizing sort of the same data. This time, obviously, we're breaking by iOS UI version. And as you can see, even with a locked device, you can see there are clear differences between the same app running on the same device, just different iOS versions, which is fairly interesting for us at least. We can also analyze different facets of the same metrics, like app startup, where I have cold and warm. In this case, we have warm startup rate on PlayStations and iPhones, so we can break by that too. A/B test, as I mentioned before, and that turned out to be a fairly popular feature. Same graph as before, same CDF, but in this case, we're comparing test cells, so different experiences the user is getting in the same test. So same amount of users allocated to that test in each cell, and we're comparing that one specific metric. In this case is details page, the time to load the details page, and this was a specific test to prefetch, different ways of prefetching data for details page, if I'm not mistaken. As you can clearly see, it's fairly different. You can clearly see that usually cell 1 for us is our control, and the other ones are different experiments. So we can clearly see that at least cell 5, it's loading quite faster. So it's tend to be really nice. We're starting to dribble into anomaly detection too. That's why, because we have so many dimensions, it's really, really hard to keep manually analyzing those things and finding weird behavior. We're still trying new algorithms. This, as I mentioned, is fairly new. In this case, I think is ESD, so the extreme studentized deviate. But in a nutshell, it runs this anomaly detection algorithm over a time series. And we try to do that with all possible combinations of dimensions. And based on those results, it actually alerts us in case something looks weird, so we can go and analyze and try to understand why that happened. We're also working on a feedback look, so we can improve things over time, improve the detection over time. Going forward on Icarus, we adding more and more metrics, namely resource utilization metrics, CPU utilization, memory pressure, and so on and so forth on devices. We're looking to add device profiling. We're instrumenting client code right now to get some profiling into clients to see, in case something regresses, we at least know where to look at. So that tends to be really, really good for us during the troubleshooting process. We're exploring different visualizations. I'm really a big fan of the frequency heat maps guy showed before. They're especially powerful for weird distributions, so I really like those, and we can get those out of T-Digest too. So we're looking to get that in pretty soon. And I'm also studying and trying to better understand the connection between this perceived performance on the client side, user acquisition, and retention. But that's all I had, and with that, I'll leave you with Vadim, which will talk about auto-scaling.
Hello. Thank you, Martin. Thank you, Guy.